expect you can hear me. It's not. So, hello. As Andy Waffer said, I'm a Debian imposter. I have come here to talk to you all, so I'm assuming you don't really know who I am. I've been doing free software for quite a long time now, and doing ARM stuff for my pretty much entire professional career, and got involved with Debian back in 2000, mostly because they had an ARM distro to work on. So, and since I started working for Linaro, which is what I've been doing for the last 4 years since it was created, I've been doing some Ubuntu things as well. I used to ignore it before that, but Canonical was heavily involved at the start of Linaro, so that was the default distro, so I got to find out how Ubuntu works as well. And I came to appreciate that Ubuntu and Debian are nearly the same thing, at the lower levels at least. So yes, I've come here to try and break down some silos. We all operate in our little segments and don't talk to each other very much, so I thought it was useful to come and talk primarily about Multiarch, although I'm actually also interested in any ARM stuff, particularly ARM64, which I've been working on for the last 4 years, Crossbuilding, OBS, and all that stuff. So this talk comes in two halves. There's the technical aspect of what Multiarch is and what it does and how it works, and possibly more interesting, the social aspect of how you make big and difficult changes in a distro like this, and what went well, what we did right, and what we didn't do right and didn't go so well. I always put this slide in because I got into this because of cross-building, and the nomenclature is confusing to anybody who doesn't do this all the time. And I will use this, so just so you know what I'm talking about, the build machine is the machine you're building on, not the machine you're building for. The host machine is the machine you're building packages for, not the host you're building on. And target is not the thing you're building for, it's the architecture of generated code from tools like compilers that generate code. What is this Multiarch thing? Fundamentally, it's a very simple thing. It's just a general mechanism for installing libraries of multiple architectures in the same file system. That's ABIs when I say architecture, so application binary interface, the calling conventions, i.e. the thing that has to match up in all your libraries in order for stuff to work. So you're probably all familiar with /lib and /lib64, which has been true in x86 world for a long time. That's the same thing, but that's the poor man's version that only does two things, 32-bit and 64-bit. That's it, you can't install any other architectures. That covers 90% of what people mostly want to do, so that's what most people have been using for a long time. But it doesn't really solve all the problems. So fundamentally, this is dead simple, but because it's a really core thing, it's difficult to change. So the basic point here is that if you install libfoo on different architecture machines, they always go in the same place. So you can't install i386 and ARMHF on the same box because they'd clash. You might argue, why would you want to? But with Multiarch, you just put things in triplet named directories, so each of these things has a place and they can all go on the same system. And you just have to tell the C library loader that the default library path has changed, and everything just works. Fairly straightforward. So the important thing is that this is a simple thing, but it's quite powerful because everything now has a canonical path. It doesn't matter what you're doing. You might be cross-building, native architectures, non-native architectures, emulating, all those things. There is just a place where that architecture's libraries and headers are found. And this path never changes. And you package the stuff up, you install the packages, it just is. You haven't got to go, oh, I'm installing it for emulation purposes, or I'm doing cross-building now, so I need to look somewhere different. All that goes away. Which is why, having done this, you don't really use sysroots much anymore. There are circumstances when you still need them. And similarly, multilib serves a different purpose. So Debian never used /lib64, which may seem odd to distros that have been doing it that way for 15 years. We always thought that native libraries should live in /lib. And that was always true, even on the older 64-bit architectures like Alpha and IA64 and S390. It was only the AMD64 people who went, well, that's no good. We want to install 32-bit and 64-bit stuff, so we'll invent a new /lib, and we'll put that stuff in there and leave the old 32-bit stuff in /lib. And that convention has since been used for newer 64-bit architectures as well. So, and then you can tell when this all went wrong when the X32 came out, because this is clearly madness. So this is just poor man's multi-arch. You know, we go, oh, we need a new thing. We'll have to invent a new top-level directory to put it in, which seems a bit poor, really. It works. So in Debian world, we've been building 32-bit compatibility libraries as -i386 packages, so package builds 64 and 32 where you need them. And most of it's gone into a massive source package with all the libraries that you wanted 32-bit versions of, called ie32libs, which is what you install if you need to install any 32-bit stuff on a 64-bit system. This was a bit of a hack, but we thought, well, we'll fix this /lib problem, and this will do in the meantime. But that was like 2001, and it grew as there were more and more things you needed. So by 2005, it was the biggest source package in Debian at 340 megabytes. Well, actually, it finished up at 340 meg before we finally killed it, with 128 libraries in it. And it was always an ugly thing, and it was horrible to maintain. So that was, getting rid of this was the main driver for going, we need to do multi-arch properly. Let's fix this once and for all. But it took a long time, because these things are difficult. So what you get if you do this is you can now have an arbitrary mix of 64 and 32-bit apps. You don't care, because now there's nothing special. You can install as many 64-bit or 32-bit apps as you like. You can cross-grade easily between architectures. Now, I have no idea whether you can already do all these things in SUSE. We shall hopefully come to that later. Some of these things you might go, hey, that's cool. Some of them you might go, yeah, we've been able to do that for years. So, so cross-grading between architectures becomes pretty much trivial, which is quite nice. It's easy to install some of the stuff for a random architecture that you can't run, except with, say, QEMU, and that'll just work. Cross-compilation is perhaps the biggest change. It's now, because the paths are canonical, you don't have different paths for compiling and from runtime. So stuff just works, and you've already got all the dependencies, installing the dependencies for cross builds just happens as part of the normal package management system. And you can get rid of all the packages that built a 64-bit and a 32-bit version. You don't need to do that anymore. You just build a native version of every package, and then you can install them side by side if you need both, or more. And of course, the main driver for this, as I say, was proprietary binary stuff that even Debian people need to install, and having that work nicely. So, things it isn't. It is not a way of installing 32 and 64-bit versions of application-level stuff at the same time. You get to install one or the other, because it's only dealing with the library part of this. Now, you could deal with binaries as well, but we haven't done that yet. And I'll come on to why. Mostly, that's sufficient for people. There are a few people who'd like to be able to do that as well. This is about ABIs, not about ISAs, instruction set differences. So a lot of people get confused about this. The ABI is just the calling conventions and the library stuff that has to match up within an architecture. It's not about have we got CMOV or not, have we got MMX, have we got whatever extra instructions that newer versions of the architecture have. So in general, those things are forward compatible. If you build the old stuff, it'll still run on the newer stuff. But if you optimize for new instructions, you can't run it on the older machines. So it is still incompatible, but it's an optimization rather than a fundamental change in the ABI. So that's why multilib is still useful, because multilib lets you install the multiple flavors of the same ABI optimized for different CPUs, should you need to do that. There's other things you could do, which we haven't done yet or are in the process of doing. So partial architectures is not building all the packages for an architecture, just a few in a different ABI. So I think the most obvious case is PPC64. it's pointless building all of Debian for PPC64. You only want to do some stuff, so I'm told. I know nothing about PowerPC. And you might as well just use all the existing 32-bit stuff and just build some 64-bit stuff. And if you can just install them together, that's neat. It saves you building 20,000 packages and having to store them all on mirrors and all the usual stuff if no one was ever going to install any of that because it was pointless. So partial architectures are useful. But we haven't actually done any yet. It's also useful for Windows, Win32 stuff. Cross-dependencies. So one of the things about dependencies, I assume it's true in SUSE as well as Debian world, is that the set is closed within the architecture. So you can install every package in the architecture using only packages from the architecture. You don't need packages from other architectures to satisfy dependencies. Cross-compilers are a bit special in this regard because you need the C library of the host architecture and stud C library and various other bits and bobs. Normally you build a separate version of those and then package it pretending it's for the build architecture. But actually you could just use the one you already built for the host architecture, and which actually simplifies your compiler builds enormously, or cross-compiler builds, which is a painful subject if you've ever had anything to do with it. So we're just in the process of doing that at the moment. You can also co-install compilers. You think, why would I need to do that? I can just do -M32 and use the 32-bit back-end, which is true in x86 world. The particular use case that came up is if you need to build Haskell stuff, big Haskell stuff, on an underpowered i386 box, sorry, AMD64 box. Anyway, if you haven't got very much memory, the 64-bit version of the compiler uses an awful lot more RAM than 32-bit because Haskell's all pointers, and they're all twice as big. So you can still build stuff if you install the i386 compiler on the AMD64 machine that you can't build on your low-memory AMD64 box. Sorry, AMD64 in Debian speak is x86_64 in the rest of the world. So people want to do this. And if you arrange your compilers properly, you can actually install them side by side. Again, that's currently underway, mostly by the guy who had this GHC problem. He's decided to do the work, and you go, okay, fair enough. Mostly people don't care. Port bootstrapping is something that's always been painful in Debian world. It seems to work a lot more easily in SUSE world. And Multiarch helps because it lets you automate the first part of the bootstrap where you have to cross-build everything. You also have to have this build profile thing to remove all the circular dependencies, which also make bootstrapping difficult. And once you can install arbitrary architectures together on a box, you can think of all sorts of other increasingly daft things that you now can do, but may or may not actually want to. So, as I said, we install things in userlib triplet instead of userlib. Now, when we spec this up, the problem is that triplets are not ABI unique. They mostly are, except where they aren't, and that's mostly x86 world, where you have i386, i486, i586, i686, Linux GNU. They're all the same ABI, but they have different GNU triplets, just ISA variations, optimizations really. And that's kind of annoying because you don't want to install your libraries to your compatible libraries to different paths. Yes, you don't want to do that. So we invented a new tuple scheme to specify these all properly, and then ended up in a big argument about whether that was a good idea or not. And in the end, it got rejected, and we went back to GNU triplets, just normalized to i386 for that ABI, and it didn't matter which flavor. They'd always go in that directory so that you'd have a matching set. Now, the way this works at the moment is you ask dpackage, the low-level packaging tool, what is the correct multi-arch name for this architecture. So it's always translated between Debian names and GNU names, and now it translates between multi-arch names as well. The problem with that, of course, is that only works in Debian world. It's a fat lot of use in the rest of the world. So this needs to move up to the LSB or some upstream tool. We've actually written one as a demonstration to go in LSB. But for reasons I'll come to later, that's kind of stalled at the moment. So that's something that still needs doing to spread this to a wider audience. So the way the co-installability and dependency between packages actually works is we add an extra field to each package called Multiarch, which basically says, is this a library, is this a tool, or can't it decide? So the names come from the dependency name. So if this library needs to depend on something of the same architecture, then it's called Multiarch same. If the dependency can be satisfied by a foreign binary, so automake, you don't care which architecture the automake is for, you just want one that works. So that's Multiarch foreign. And if something's allowed, then it depends on what you're depending. Some packages have both libraries in them and tools in them, and it depends what you're using them for in this particular build dependency, which one you wanted. So some packages have to be marked both allowed, and then the dependency specifies which architecture you wanted it for. Now, of course, not all the files in a package are architecture dependent. They're not all actual .so files. There'll be a copyright file and maybe a change log and maybe a whole load of stuff, indeed header files. So the package manager actually does reference counting to say, well, we've installed this package 3 different times for 3 different architectures, so don't take the change log away until you've actually removed them all. And that does, of course, mean that they actually have to be the same across architectures. We used to not care if for some reason, usually there's a date in a help file. If they get built on different days, they end up with different dates in, and now they're not byte identical, and this all explodes. So we've suddenly had to start caring about that stuff and fixing it up. So the way you actually use this, it's dead simple. The low-level package manager, dpackage, is responsible for what is the native architecture. So you just say dpackage add architecture, some other foreign architecture. You can add as many as you like, and you remove them in the same way. Now, you can't actually remove them until you've taken away all the packages of that type. So if an architecture has to be enabled if there's still packages of that type installed on the system. So an apt is the higher level package manager, equivalent to zipper, and you tell that where it can get packages of different architectures, because not every repository has all the available architectures, and especially if you're doing a new one, it's only available in your crazy Bootstrap repo that you've just invented. And Ubuntu has always split its stuff up into x86 archive and everything else at ports. So you have to tell apt where it can find things or where it should look for things. It'll still work if you don't. You'll just get a lot of couldn't find file such and such because the indexes are missing. So the way this works, if you've got a machine where you've already installed libatter, assume this is an AMD 64 machine, 64-bit machine. If you just ask for install the i386 version, it will install that and the corresponding libc dev and the corresponding library and the corresponding libc. The dependencies just get solved automatically because this depends, and the dependency is propagated through that architecture. Dead simple. So yes, I should apologize for the fact that all this is written in Debian terminology, because I have no idea what the RPM and zipper equivalents would be. But you basically, so this is the case that the original work was done to solve. You just set up the new architecture and update your lists of what's available, download a deb that some vendor has kindly provided, and install it. And then apt-get will just sort out the dependencies and install all the 32-bit libraries that Skype needs, because they only supply a 32-bit version, or at least they did. If they put it in a repo, then it's even simpler, and you can just apt-get install something :i386. So this is quite cool. And once we had that working for Flash plugin, probably 3 years ago now, that was kind of the initial stage of this deemed working. Cross-grading is also cool. The thing that defines what the native architecture is the version of dpackage on the system. In fact, something has to. What It's not the kernel, because we're habitually, for years, we've all run 64-bit kernels and 32-bit user spaces. So it's the version of the package manager. It's the architecture of the package manager defines what the native architecture is. So if you want to cross-grade, you just download a new version of dpackage and a new version of apt and install them. We do it in this download-only way and then install them sort of by hand, because that stops it exploding and getting confused and trying to replace everything of itself for another architecture all at once. So this used to blow up when it tried to replace the tar that dpackage was using underneath itself as it unpacked the new one and got confused about which architecture it should be running, but we fixed that now. So this is nice because people have been installing 32-bit user spaces for years and quite often want to upgrade these days. That's now easy. Cross-building, that's what got me into this. There's three major things you have to worry about. Installing build dependencies is the thing I spent a lot of time on over the years. If you want to cross-build whatever, it needs a whole load of stuff for the build architecture, for tools at runtime, possibly for tests, and you need a whole load of libraries and headers for the host architecture. And working out which build dependencies are for which architecture is a problem. I'll come on to that later. Linking libraries is a bit of a pain. I'm going to come to that later. And running tools of which you've just built during the build and of the wrong architecture is the other thing that tends to catch you out. And Multiarch helps to varying degrees with all of these. So let's take a nice simple example, ACL, which just depends basically on libatter and thus on libc. So it's got a build dependency list like this: deb helper, autoconf, autotools dev, dpackage dev, and libatter dev. Now, so it's not obvious that this last one, libatter, is needed. You need the host architecture version, but dpackage dev and autotools dev are things you need for the build architecture, because they're actually build tools even though they end in -dev. So I helped with a tool called xdeb, which we used for some years, which did this the dim way by looking at the list and going, well, if it's called -dev, it's probably a development package with headers in, so I should install the host version. Oh, except for this long list of exceptions. And if it starts with lib something, then it's probably a library, and I should do the same thing. Oh, except for this long list of things. So it was pretty thick. But I mean, actually, that worked quite well once you had most of the important exceptions in the list. But this, because we put it into the system and the dependencies just are, it all works very nicely, once enough packages have been annotated with multi-arch information. So now you just say, so apt-get build-dep, package name, is the way we install the build dependencies for a package. So now you can say apt-get for architecture, in this case ARM64, well, building for that on any machine, the build deps for ACL, and it goes, okay, so we need the ARM64 versions of libc and libatter and libgcc and GCC 4.8 base, and build architecture versions of anything else, except apparently we need Linux libc dev as well. So it just works. And this was the point at which I went, this is cool, actually. I'm starting to be impressed with this. It's really, really nice. Having struggled with this problem for years, it's just solved. It's great. I'm very impressed. Library paths. So this used to be somewhat painful. So in the kind of classic cross-compiling scheme, things used to go in user triplet lib, even when they were normally in user lib, and correspondingly headers went in user triplet include. But obviously, so the link time path is different from the runtime path. And similarly with sysroots, although rather more regularly, you have just a prefix, and then it all looks the same underneath that, which is pretty much how everyone does things these days. Under Multiarch, the link time and runtime paths are just the same. It doesn't change. It's a lot easier to get it right. It removes all the opportunities libtool had to make your life miserable by getting it wrong, which, if you've ever had anything to do with it, you'll discover it does regularly. In fact, libtool is pretty much irrelevant once you've got a system like this. Obviously, it still tends to get used and waste a whole lot of CPU cycles running massive, pointless shell scripts, but the net result is that it does nothing. the problem of random build time things. So I'm a fan of proper cross-compiling, where you try not to run things of the wrong architecture at build time, but it's increasingly difficult. And certainly, just being able to, if you've installed them, is handy, and glosses over a lot of imperfections in various people's cross-build foo. And obviously, the dependencies just get solved automatically. So, and this kind of gives you quite a lot of what Scratchbox did, but in a more orthogonal way. So you can choose whether to put a certain amount of host architecture stuff, which is only being run with QEMU, into a system, or have real native packages. You can just mix them up, and by and large, stuff works. You've got to be a little bit careful doing that. There's various things that can go wrong, but you can now do that. So cross-building is now pleasingly simple. To be fair, this is actually working nicely in Ubuntu at the moment. It's not working nicely in Debian yet, because a few key things like libtool have not been converted. So, in fact, very few packages will work just like this right now. But in Ubuntu, hundreds and hundreds will, thousands probably. So Crossbuild Essential is a package, just a meta package we made up to install the toolchain and the libc of the host architecture, and a few bits and bobs, which make sure you have all the auto foo for the host architecture configured. So you just install the build deps for the host architecture, get the source, and build it for the host architecture. Absolutely the standard tools. It's not a special version of apt-get, it's not a special version of dpackage build package, just the normal stuff. And now it just knows about different architectures and does the right thing. Very sweet. Obviously, for real cross-building, you often want to turn off tests, because so no check is the standard way of saying don't run the tests, because if they're just going to run all the stuff you've built, okay, you could run it under QEMU, but that's usually pointless. And you do usually need to tell autoconf on autoconf packages where to find its how big is a float type info that it can't generate at runtime. And so that the standard, or in practice, you don't usually do that. You just use sbuild, which is our standard build this package. So now you can say build this package for architecture blah. It's all quite slick. So in order for all that cross stuff to work, as well as doing library multi-arching, we have to do header multi-arching. So that was actually a second part of the spec. But it's it was done under a slightly separate specification. And there's a few other bits and bobs you have to deal with. So a smaller number of dev packages have been converted, but quite a lot have been done. So in order to make all this work, you've got to change a fairly small number of core tools, but slightly more than we were expecting. In principle, it's just the C library loader is the only thing that has to know that all the libraries come from a new place. The package managers need to understand about the new dependency arrangements, and the compilers need to have new default library and header paths. Actually, it turns out there's other things, like make has this special -l syntax, knows where libraries are, so you have to tell it, and all the other makes, and various of our tools, and things like libraries, other languages that link with C. So libjna is the Java thing for linking with C libraries, which needs to know where the libraries are. So there's quite a lot of telling things that the default library path has moved in various packages. Once you've done all that lot, pretty much everything, so long as it asks the compiler and doesn't try and work it out itself, just works. So upstreams generally don't have to change at all, unless they were doing evil stuff anyway, which was probably wrong. There's other things you could do with this. So as I said, it doesn't do binaries, only libraries. You could think up a scheme for that. It's kind of thorny. So far, not enough people have cared to worry about doing that. Maybe one day. One thing that is interesting is doing this for Windows. A lot of people build a lot of Windows software on Linux, and just making it another architecture and having a place to install the libraries and using the standard package managers to deal with the dependencies, and having normal packages which you can install is all quite attractive. The main problem is that it's not a POSIX architecture, so it's a bit more different than the others, which means that, for example, your user include headers used to be architecture independent. If you add non-POSIX stuff, that changes the definition of what architecture independent means. So more things have to be put in the architecture subdirectories instead of in the common, the same everywhere, because that set has shrunk. So Stephen Kitt is keen to make this work, and if anybody else cares. So I gather that SUSE actually has more packages which build just Windows binaries than any other distro I'm aware of. There's hundreds of them. You could throw all those away because you just build them from the standard packages. That may or may not be attractive. Now, it isn't quite perfect, so there are some architectures you can't co-install, only because there's one file which clashes. But it's the one file you can't change because it's the one file baked into every binary you ever built for that architecture, which is where the loader lives. So back in the day, loaders always lived in lib.ldso.1. So there's a range of architectures that are still using that. And so you can't install M68K on an HPPA system. You can install every other package in the system, but there's only one loader, and it's got to be one or the other. That's a pain. Fortunately, the combinations that don't work are ones that nobody cares about. So actually, this isn't a real problem in the real world. But it is unfortunate. And you could fix it by making the loader smart enough somehow. So we have got through to the libc people that making sure all new loader paths are unique is a really good idea. And we've done that in ARM64 and PPCEL and all the more recent architectures. And there's now a nice list of all of these at that URL. It used to be quite a hard thing to discover what was already used. So the other thing that's a little bit broken is that this was designed assuming that libraries always needed other libraries of the same architecture. That's perfectly true in kind of C, C++ world. But if you have embedded languages, they can have modules which are either architecture dependent or architecture independent because they're entirely interpreted. And you can get a situation where you have a module A, which is for an architecture, which depends on module B, which is all just Python, say. But then that depends on something else, which is C again, or linked to C. And that needs to be the same architecture as the first thing, and it doesn't propagate down under the existing scheme. So we've had to think about that very hard. We had a brain-melting session at the last DebConf with about the 8 people in the world who actually understand this shit, all going, oh, Jesus, my head hurts. We think we have a plan. So the question was, did we have to actually expand the spec to deal with this, or could we just deal with it by being a bit smarter about how the dependency is done? We think we can just be a bit smarter. In practice, this happens very rarely. We have Multiarch Python and Perl in Ubuntu for a couple of years, and nothing important breaks. You can work around it. So, some idea of how this came about. As I say, back when AMD64 came out was the original, oh, we don't like that very much, we should fix this. But it took a while for people to really start to do anything about it. But it was 2004 we started, so it took kind of 7 years to get it into a distro. And it's going to be, it was in Debian's last stable release last year, so whatever that is, 9 years. It takes a while to get these things done. Part of the problem was that the set of people that understand a problem like this and can spec up a spec that's actually going to work are busy people who haven't actually got much time to work on it. So it got talked about for a long time before somebody actually went, no, we need to write some code and fix all this. And then said there was a depackaged patch first in 2008. If you see here, it didn't actually get uploaded until 2011, and that was mostly due to the depackage maintainer being a pain in the arse and not liking what we'd done with the tuple names and having to go back to triplets and arguing back and forth, and also simply going, yes, I will do that, and then not doing it for about a year. And one of the problems with Debian is that package maintainers pretty much have a veto on their packages. You know, in theory, other people can upload them, but in practice, we just don't, if agreement hasn't been reached. So it stalled for a long time until Linaro stepped up and paid somebody else to write the code and argue with the maintainer for another 3 months to get it in. So that didn't help. But to be fair, the implementation was better as a result of that argument. You know, the maintainer was right about some things. So, you know, this produces very high-quality code, this process. It's just really slow. So, yes, so it was first working in Ubuntu Precise in 2011, and the last Debian release had Multiarch and some packages. In fact, I think we are, yes, a list. So the core stuff was done in Precise, and then we had sort of 350. I don't quite understand why there's so many more libraries in Raring than there were in Precise, but apparently there are. We have 700 odd by stable release last year, and we're up to over 1,000 now, and we'll probably have basically all the libraries done. So as you can see, this affects all your libraries, but only a relatively small fraction of the rest of the system. You know, it's basically the build tools set. Anything that's a leaf package never needs to say what multi-arch it is, because it doesn't matter, it's just a leaf package. There's a whole load of stuff that's not really involved. So I don't know what percentage will eventually be touched. Maybe 10% of the archive or something. But it is all the stuff people actually use. So, onto the social aspect of this. It's a very good example of a difficult distro-wide change to, you know, not just distro, but the Linux file system hierarchy. How do you make a change like this? Because nearly everyone will go, oh, really? Do we have to change that? It's been like this for a long time, you know. So one of the things we learned was that writing down a spec was amazingly helpful. We didn't do that for years. We had meetings and wrote minutes, but we didn't write down. So the problem is that you know, a typical free software meeting looks like this, and some people stand around, they talk to each other, and they might even agree on some things, or at least, you know, these three did, and those two did, and they didn't necessarily agree on the same things. And none of them went down and wrote it down in a proper spec afterwards. They might have written a wiki page, but it was a bit vague. So one of the things that happened in 2009 was writing down an actual specification. The other thing is, because you need to go to your package maintainer people and say, right, we want you to implement this. And they all, what exactly? What exactly happens about this, that, and the other? So a good spec was enormously helpful and actually got the thing done in the end. Limiting the scope was the other thing that was important. For a long time, the early discussion was all about, well, we could multi-arch the world, we could go crazy, we could have, almost anything's possible. And yeah, it's all possible, but if we want to do it this century, maybe we should just let's just do the library part for, you know, and not worry about the cross-building part, and we could multi-arch all the binaries as well. So limiting that helped a great deal to make this something that only took 10 years rather than 20. And getting everybody involved is the other thing that's absolutely critical, who's going to be seriously affected, so that when you've got an agreement, it's actually something that you can defend, and you're not going to get someone coming along later saying, but it doesn't work for X. And you go, oh, bollocks, really? So we did a pretty good job of that, and splitting up work into pieces. Again, working within a distro, you can't break it for a year until everything's changed. That's hopeless. So you can't have flag days. And also providing good info for everybody else, right? There were basically 8 people did this. The other 992 Debian developers didn't really care, except insofar as their packages broke and they had to change stuff, and they'd like it to be as simple as possible. So we wrote pretty good docs saying, if your package is built with this tool, you need to change this. And for most packages, most library packages, it's pretty boilerplate stuff, actually. You have to add a */* in a couple of places and change your deb helper compatibility level to 9, and it would automatically do the right thing. So giving people clear instructions saying, if you use this, do this. Most people were happy with that, and they just did what they were told. And it takes quite a long time to filter through the system, waiting for new uploads and so on, but that all worked pretty well. And we didn't get a whole load of complaining about this craziness. There was a small amount of complaining about the craziness, but not much. So, that all went well, but, as you may have observed, this has only been implemented in the Debian X system, pretty much Debian, Ubuntu, and derivatives. The whole RPM world has basically ignored it. That was never the plan. Now, the work was done within a distro because there was a set of people who cared enough to get it done. And that's the unit of what you work in. You can't try and change all the distros at once unless you can do it upstream first. And a change like this is very hard to do upstream first because people kind of go, I don't even believe this is going to work. It'll just all break. Go away. So we did this, and actually when we tried to upstream things, we found that we hadn't quite got everyone involved. we had the GCC people and the libc people and various toolchain and autoconf and a lot of package people and cross-building people and so on, and that was all good. But the problem was that we had the Debian GCC and eglibc people. And in actual fact, it turns out most of that work is done by Red Hat. And maybe you guys, I don't know. I thought about it. I've only ever met one libc person who wasn't the Debian guy in 15 years of going to conferences like this. So, I've never talked to those people, and I think that was true of most of us. So we didn't even realize we weren't talking to the right people until quite late when we presented all this stuff, and they went, what is this craziness? From their point of view, this had just come out of the blue, and it was madness. And so they were quite grumpy about that and said, no, we're not putting that in, go away. So in fact, ARM hit this problem. They decided to use Multiarch for the ARch64 port from the beginning because it seemed like the future and the way forward and a sensible way to do things. And then when they tried to upstream things, they went, oh, you can't do that. We're not having a default loader path of lib triplet LDSO. It's just stupid. No, it's not. It's really sensible. Take it out. So sadly, that didn't happen. But they did get to keep /lib instead of /lib64, which is good from our point of view. So we ended up with a bit of a fight, and the thing kind of stalled. So we didn't get it into the LSB, and some patches are in GCC, but not everything. There's still a Debian Delta. So basically, that was a failure. This did not go quite the way we planned, and it was almost entirely because early meetings back in 2008, 9, 10 did not have the right glibc and GCC people there. And they didn't get to hear about it for another 2 or 3 years, which was too late. So lesson learned. That was a problem, and it's caused this all to kind of it's got as far as it has, and it's very good. We like it, but it's not used everywhere, and it's now awkward. If you want to upstream changes about this, to kind of change upstream defaults, that's a bit difficult to do because most people still feel the kind of multi-lib way of doing things, because multi-arch replaces part of multi-lib. You can kind of use either to get the same effect for many purposes. And GCC people quite like their multi-lib stuff, but we don't use it for that. So you get some friction there about which way, and upstream are kind of going, well, which configure options do I use? I don't bloody care. What's the right thing? So what are the defaults? So that's kind of where we've got to. I meant to say, I'm not here to persuade all you lot, it's not that many all, that you should adopt this. But I did want people to understand why we thought it was worth the effort and that it is quite interesting. And mostly that if we can get better understanding of this issue, then we should at least have less trouble with upstreaming stuff. So really these changes need to go into glibc now, and we're working on that. But some people like it and some people don't, and there's a question about whether it should become defaults for anything, or how configure should work to decide which way you're building stuff. And at least if other people aren't saying no and understanding why it's useful, that will help get things done upstream. So yes, that's where we're at. So like I said, you don't need multi-arch because you can do nearly all of these things some other way. You can use sysroots, or you can use a small subset of /lib top-level directories, and you can use /emul directories, and so on. But multi-arch does kind of all of those things at once in a nicely orthogonal kind of way. And then, having used it for a bit, I've been really impressed with that part. It just feels like the right way to do these things. And the only reason we didn't was because it was easier to do something else for each of these problems as we went along. So now we've actually done it right. It will be nice if we could get this spread through the rest of the world. But I have no idea how to get there from here. So, I'll shut up now. Does anyone else have anything to say?
One potential issue is that OpenSUSE requires, or OpenSUSE would like to be binary compatible to an extent with RPM counterparts. Mm-hmm. So You get people, certain software vendors that will generate a deb and an RPM. That's it. They just produce 2 binaries, one for Debian Ubuntu and one for Fedora OpenSUSE. Say OpenSUSE adopts Multiarch, how would that impact that scenario?
So you don't bake the only thing you bake into the binary is the loader path. And that's why we've gone to a lot of trouble to agree the loader paths, to agree the loader paths for architectures across distros. So on ARch64, everybody uses the same Linux loader path, and on ARM HF, and everywhere else, as far as I know. And the loader knows where to look for the rest of the libraries. So it doesn't matter if you've moved all your libraries. That's why LD preload works, and so on. You can change the library path. That's not a problem at all. Building stuff is a little bit more involved because that affects your compiler setup. But for just delivering binaries, no problem at all. Shouldn't matter.
Right. So, I mean, somewhere along the line, I still fail to see the actual problem that you're solving. Right? I mean, so now I can have libraries, but I can't have the binaries. So that means I cannot use one disk and mount that as the root file system of a power box and an x86 box, because the binaries are still not separated. So I'm still tied to having only one architecture per root file system.
One primary architecture, yes.
Right.
That's right. So yes, so as I said, that is a secondary thing which could be done, but nobody has cared enough to do that. But like I say, this is still useful for the various things that I have mentioned, cross-building, and it makes your build setup a lot simpler. I mean, again, you've already fixed this once with special casing /lib64 for some architectures, and knowing to look in other paths for emulation libraries and so on. So yeah, you're right that it doesn't have a killer thing that makes it amazingly better.
Right,
because
and
we've already solved these problems different ways.
Right, and I mean,
but most of that's cruft, and some of it's really hacky.
Yeah, but I mean, the lib64 stuff was fixed, I don't know, 20 years ago by
15 actually, yeah. It's kind of 2000-ish, wasn't it?
Well, more than that.
Right, okay.
By IRIX and AIX when they started being 64 and 32-bit, right? I mean, that's where this really...
Those architectures still used lib. It was AMD64, I think, was the first one that decided it wanted a different direction.
No.
No?
No.
Okay.
In the Unix world, we had lib and lib64.
Okay, maybe I guess that's where it came from.
AMD didn't...
But we never had a Debian IRIX release, so I didn't know that.
Right, but I mean, so IRIX had it, Spark had it, Solaris, whatever it's called. So, I mean, that problem is really, I mean, that goes way back.
Mm-hmm.
And I guess, I mean, we just adopted that in the end, right, in the Linux world,
right,
because that's the way it was done in Unix. And so, yeah, I mean, I don't see the killer feature this has, and for the building, I mean, that's something that we as developers have to worry about, but the users in the end, they couldn't care less, right? No. So if I can go to a user and say, look, you can mount one root file system on your power box, x86 and it's all the same root file system, mm-hmm, then maybe then I can have user draw, but without the user draw, I don't see that as developers would go through the effort that you guys went through. I mean, this is crazy.
Most of the benefit accrues to the developers as a harder cruft you can take out. And of course, the problem is you can't actually take it out if you've only done it in part of the ecosystem. So upstream now just has 2 versions of everything. Well, actually, it mostly doesn't affect upstream because you pretty much just configure with --lib dir equals blah. Normally you configure with user lib. Now you configure with user lib triplet. So for most upstream packages, it doesn't make much difference. It's the toolchain stuff that's messy. And yes, when you start going, oh, now we want x32, so we'll add a /x32, and you kind of go, yes, well, kind of makes sense once you've headed down this path. But yeah, you're right. Most of the benefit, there isn't any user benefit in it. Well, so having everything available for the other architecture. So for i386 AMD64, you've got to build every package that you want to have a 32-bit version available of that on 64-bit systems. Somebody has to do the packaging for that, right? It doesn't just, you don't just get it for free. Maybe you do, but
well, we have a baselabs conf where you just say, if I build this i586 package, also create the 32-bit package for me, so it just copies the files. We don't build it twice.
So you copy it out of the 32-bit build into the 64-bit build?
Later on, yes. In the repository it will be copied over.
Right, okay. So I guess that's the equivalent of Debian's depackaged cross, which takes an architecture and munges it into a different path in another package.
Yep.
Okay.
So my question would be, how would you solve the binary side?
Oh dear. I have not sat down and thought about that at all.
Also with prefix paths or suffixes on the binaries?
Yeah, I mean, there's something clever with paths, but it's a bit tricky because a lot of things specify paths. All those hash bang paths. That's the bit that you kind of go, what do you do about that? And there isn't an obvious, painless. The library thing was nicely contained within the loader, pretty much. So that was easy. Binaries is definitely harder. You could just change it. You'd have to, I guess you'd need to teach things that read bang paths to go, well, I'll look here.
Yeah, or you bind mount some specific directory.
Yes. So it's not something I've sat down and talked about, so I'm not going to pontificate here about what you might do. I don't know. I'd be happy to talk about it with you, but I've never really thought about it. Because we want to get this bit done first.
And you have to get everybody to agree on the loader path. Right. I mean, the loader has to move. There's no way. There's no other way. The loader would have to move. If you were able to use the same root file system on multiple machines, the loader would have to move so that you find the right binary loader for that architecture. So the loader has to move, and you have to do tricks with the binary.
Well, if you say you have user bin, like user triplet bin, and you bind mount it to user bin, you could do the same for /lib. Then /lib would be just a bind mount to the I-specific directory.
Yeah, but who does the bind mounting when?
Init-ID. The init-ID. That is I-specific.
Yeah, there has to be some code of the right architecture at the beginning to actually run on whatever hardware you've put it on. Is the
you have the init-ID, which is R-specific, that does the bind mount.
Okay, right, yeah. So you supply an init-ID that's of the right architecture, which can then do the right things. Yeah, that would work. That's
the only
potential.
Potential I see it without much pain.
And we've already pretty much made a world where nothing works unless you've got an init-ID anyway. So that's not a big fight anymore. So, yes. Any more? Well, thank you for listening to my craziness. If anyone wants to talk about it further, I'm here all week, as it were.